Okay, the lesson for today, we will be calculating the transformers. Single phase transformer, we'll be doing the calculations on single phase transformer. Here's our first problem. It says a single phase transformer is rated at 100 kilovolts amps and has the 10 ratio of 10 to 1. That's how you can write the 10 ratio. Then it says calculate the secondary voltage if the primary voltage is equal to 2.2 kilovolts. Now, if you notice here to this question, the only values that we have a 10 ratio, then we have a primary voltage, and then we have our power. That will be our input power, which is 100 kilovolt amps. So now by looking at this thing, I think the first thing you do is to consider the ratio. The ratio will be always divided into both sides, which that will give you a half. So now what we will do, we will divide the ratio to the number of the voltage that is known, which is our 2.2 kilovolts. And then by doing that, we will be able to get our V2, which is the secondary voltage. So whatever we get there, it will be our secondary voltage, because that's the one that's not known in the first question. So to calculate this, let's go for it. V2 will be 2 equal to V1 over 10, which is that's our 10 ratio. Then is equal to 2.2. Okay, let me put it like simplify it, and it's 2,200 to multiply the K, which it stands for 1,000, and then you multiply it on 2.2, and then you get 2,200. Then you put our 10 ratio, which is 10, and then it equals to 20 volts. So that's our first value that we've got. Then the second question, it says calculate the primary current. The primary current if the secondary current is drawn from, if 200 amps is drawn from the secondary current. So now we have to calculate the primary current, which is I1 if I2 is equal to 200 amps. So now to calculate that, we need to just we've got the known value of 200 amps, which is the secondary current, the current of the secondary side. So now we need to use V1 over V2 is equal to I2 over I1. Remember, I2 is not saying the same as the times and the voltage, it is always on top. So that will we have to manipulate this formula, which will give you are looking for I1, and I1 is equal to V2 times I2 divide V1, and then that will give you, let's put the values there. V2 is 220 times I2, our I2 is 200, and then we divide that by V1. Our V1 is 2,200. Then that will give you the value of 20 amps. So that's how you determine the primary current. Then we go to the third question. Then the third question says calculate the maximum allowable secondary current. The maximum allowable secondary current. To calculate that, we will use the formula of the power, which is S is equal to VI. Remember, we are checking the maximum allowable secondary current. So we are allowed to use this one. Then I will say I maximum times, is equal to S over V, which is that will be our secondary voltage. And then we substitute the values. That will be 100,000 divided by 220, which is our secondary voltage, then we will get 4.55 amps, which is that's 454.55 amps. Then we need to draw our transformer here, just to substitute the values or put the values in that transformer so that we will know what we have and what we don't have. We put the current direction, and then that will be S is equal to 100,000, okay, let's say kilovolt amps, and then we put V1 is equal to, our V1 was known and it's 2.2 kilovolts, and then N1 is not known, then I1 is equal to 20 amps, and our I2 will be equal to 454.55 amps, and then our N2 is not known, and then the secondary voltage is 220 volts. That's our secondary voltage. That's how this thing is done. Then you must always remember to divide your ratio if you don't have enough known values to calculate the secondary voltage of a single phase transformer. So that's the lesson for today. I hope it's clear and you can do it on your own. Thank you very much.